Recording. So let's take a look at our papers. 7.4. Akira, go ahead and read that for us, please. No, the top, just the title of the. Right here. Okay, applying properties of similar triangles. So we learned about similar triangles, right? That if triangles are similar, then the ratios between the sides are the same, right? Like it could be twice as big, and then both sides would be twice as big, or maybe it was half, and so it was half the size, and all the sides would be half the size. So we learned about similar triangles, and today we're going to be applying some properties of similar triangles. So go ahead and read Theorem 7.4.1 to yourself. Read Theorem 7.4.1 to yourself. Okay, Theorem 7.4.1 says, if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Well, here you go, look. Here's a line. It's parallel to this side, so it divides these sides proportionally. Well, what does that mean? Well, first off, you guys can fill in this blank here. What is it? What goes, the parallel line divides the sides? Proportionally. What does that mean? Well, the fraction or the ratio of the green here, which is AE, over the yellow, EB, so the green over the yellow, is equal to the ratio of this side here, AF, over FC, which is the yellow. So take a look at this. What is it doing? This line is dividing both of these sides, you see? But it's dividing it in a type of fraction. Like if this is 3 times as big as this, then this is 3 times as big as this. You see? Does that make sense? So the fractions are the same. The green, AE, over the yellow, EB, you see this? Is equal to the green, AF, over the yellow, FC.
How is it equal?
Because since this line is parallel to this side, then it's always equal. The ratio is always equal. And that's a property of similar triangles.
So which part's the ratio? Like the sides?
The ratio is this over this equals this over that. You see?
Okay.
That's what it shows. AE over EB equals AF over FC. Does that make sense? Okay. So that's that. Now we have an example. So go ahead and read example 1 on your own and try and make sense of that. And really think about it. Try and figure it out. If you're spacing out right now, it's not the time to space out. It's time to think.
So I'm confused too.
Well, you're looking at the example first. See, the example's in the blue box here. So you're looking at this because this is showing you an example of how you can do a certain type of problem. So think about it, read how it's showing you how to do it. What is it asking for? How is it doing it? So engage your minds with the process. All right, so let's take a look. What's it telling us to find? Well, it's asking us to find CY. Well, that's right here. Well, I know that this line here is parallel to this line, so I know it divides the sides proportionally. So that means this green over the yellow is equal to this green over this yellow. Okay, it's dividing these sides proportionally, so it means this over this equals this over that, right? Or CY over 10 equals 4 over 9. And that's exactly what you see here. They do it a little differently. They do 9 over 4 equals 10 over CY. You see that? And then they cross multiply, right, to get 9 times CY equals 4 times 10. Does anyone have issues with cross multiplying, or is that pretty simple? Okay, so 9 times cy equals 4 times 10. And you end up then dividing both sides by 9, and you get 40 over 9. Or simplifies to 4 and 4 ninths. Does that make sense? Okay, so go ahead now and find Pn. That's this side here. See if you can do that. Go ahead and do that example yourself. So it should be 2 over 5 because you see over 2 over 3. So look, it could be 5 over 2 equals Pn over 3. You have to make sure you're doing this side. So it's this over that. This. It doesn't say about the bigger and smaller. It's just the one that's attached to the vertex. You see this? So this side corresponds to this. And this corresponds to this. So it could be 2 over 5 or it could be 5 over 2, but if it's 5 over 2, then it's 15 over 3. Because they just said 9 over 4 equals 10 over cy. You don't have to necessarily do it in that order. It's just you have to compare the right ratios. You just have to make sure you're setting up the ratio correctly. Just to show that they're multiplying by Pn.
So you don't have to
You don't have to put in parentheses. Yeah. Okay. Yeah. Okay, so let's take a look at this. So we have find Pn. Alright, so we have two sides of a triangle. We take a look and we see that this line is parallel to this line. So it means it divides the sides proportionally. So I'm going to highlight the green and the yellow. So if you have like colored pencils and on a test you want to mark it up, you can go ahead and do that. But the point is that you have to make sure that the ratio is the same. So I'll do green over yellow. So Pn over 3. This over this is equal to this over this, or 5 over 2. You see, you have to set up the ratio correctly. If you did 3 over Pn, then that would be equal to 2 over 5. Do you guys see this? Okay. So you could do it the other way too, but this is the way I'll do it.
So, but do you want to start with the point is?
You can. It doesn't always have to be that way. But like,
You should do it.
yeah, sure. It makes it easier. I mean, if you want to just do it in one specific way, sure, but you don't have to. The point is, I could do 3 over Pn equals 2 over 5.
Yeah, I put 2 over 5 equals 3 over Pn.
That's fine. Or you could do Pn over 3 equals 5 over 2. Either way is fine. It's fine.
What if you don't get the same answer?
You would get the same answer. The only way you wouldn't get the same answer is if you did like 3 over Pn equals 5 over 2, because those aren't equal. See? It's like the smaller over the bigger is equal to the bigger over the smaller. No. It will always have to be in correct order. Exactly. Alright, so then I just multiply both sides by 3, which is the same as multiplying by 3 over 1. I get Pn equals 15 over 2, which is equal to 7.5. Does that make sense? Okay. So that's that one.
How did you get this down from 5?
15 divided by 2. Just divided by 15 over 2. The way that you have it is different. The way that you have it is different. So if you did this, guys, 3 over Pn equals 2 over 5. That was correct, but you have to then cross multiply. 3 times 5 is 15 equals 2 times Pn, and then you divide by 2 and you get the same answer. Pn equals 15 over 2, or 7.5. So either way you'd get the same answer. Yes, sir? Not right now. Okay. Alright, let's take a look at this next one. Alright, Theorem 742. Go ahead and read that to yourself. Okay. What is this saying? If a line divides two sides of a triangle proportionally, then it is parallel to the third side. So look, this one is basically saying the converse. Look, converse of the triangle proportionality theorem. Okay? If you flip back to the first page, that was the triangle proportionality theorem. Okay? So we learned the triangle proportionality theorem, but now we're learning the converse of the triangle proportionality theorem. And the converse of the triangle proportionality theorem says that if a line divides two sides proportionally, so the ratios are the same, then the lines are parallel. Okay? So the question would be something like this. Verify that MN is parallel to KL. You see? So I'm verifying that this line is parallel to KL. Alright, well, how am I going to do that? Well, I have to check the ratios. So it checks the ratio of 42 to 21. 42 over 21 is 2. And it checks 30 over 15. Well, 30 over 15 is 2. Are those ratios the same? Yes, they're the same, so therefore those lines are parallel. Does that make sense? All you have to do is check the ratios, and if you check the ratios and they're the same, then the lines are parallel. Yes, sir.
How would you check to make sure that both are the same? Because for to check it out, I can only give one of them.
Yeah, but look, if you read this, it tells you the details.
Oh, it says it for the next one?
Yeah.
I
So,
didn't see that. All right.
so look, go ahead. In number 2, you see in number 2 it says AC is 36. So it's 36 from here to here. But do I need AC?
No.
What do I need?
80.
AD.
Subtract.
So 36 minus 20 is 16. Good. And then it tells me BC is 27. Right? But do I need BC?
12.
No, I need BE, which is 12, yes. Good. So once you have that, now you check the ratios. So go ahead and check those ratios.
We're doing the example.
Yeah. So you're verifying whether these two lines, DE and AB, are parallel. So you have to check those ratios. Well, on this one, you could divide them evenly. Here, you can't divide them evenly, so you just simplify the fraction.
Which one?
And you just get one answer.
I don't think you do one.
All right, let's take a look. So I got to check the ratios. 20 over 16 equals 15 over 12. 20 over 16 equals 15 over 12.
You don't put 20.
Oh, sorry.
Oh, okay.
So I have to check the ratios. So I have to check them. The first ratio, if I highlight it in green, I'll highlight the ones close to the point in green, and then away from it in yellow. So my two ratios are 20 over 16. You see? 20 over 16. What?
Because they're the same.
So our first ratio is 20 over 16. But we want to simplify that fraction as much as we can. So what's the simplifying factor? 4. Good. So 20 divided by 4 is 5. 16 over 4 is 4. So that's what that ratio is. Then I check my next ratio, which is 15 over 12. Does that answer your question, Marcus?
No, I did it wrong, I think.
Okay, what's the simplifying factor here? 3.
What's
So I do divide by 3, and I get 15 divided by 3 is 5. 12 divided by 3 is 4. Are those the same ratio?
Yes.
Yeah. So it's cool.
Is it okay if you did backwards?
Yeah, and then it'll be 4 over 5. That's
Yeah.
fine.
Can you do 2 also if you want to?
You could do 2, but you wouldn't end up with a fully simplified fraction. You'd have to do it by 2 again. Okay, does that make sense to you guys? You see what we're doing? We're just comparing the ratios to make sure that they're the same. If they're the same, what does that mean? It means that DE is parallel to AB. Does that make sense? All right. All right, next. Two transversal proportionality. All right, go ahead and read that over. Read that over. Next side. Let's see if you can figure it out. What it's saying to you. You read the conclusion and mark it up. Guys, if you want to get like highlighters or colored pencils or something, it's going to help you. Okay. If 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. Let's take a look at this. Sounds like a lot, but what does it mean? It's the same deal. You see, these lines are parallel. So since these lines are parallel, then AC here is the green one, and BD is the green one here. So AC over CE, the green over the yellow, equals BD over DF. You see that? So it's very similar to the triangle. It's just dividing these lines proportionally without it being a triangle. You see that? So it's still green over yellow equals green over yellow. It's the same deal. Okay? So you just got to figure out which is which. All right? And then go ahead and take a look at the example number 3. See if you can figure that out. So take a look at example number 3.
That's what you're just saying, Max. You can't use it.
How many months balance each other? So a month and play will balance each other.
Obviously,
Just have to figure out how many months. Yeah. All right. So the tough part about this one is that it's just like hard to tell what the lines are because it's like the picture's a little confusing. But these are my lines here. Those are my lines there and there. And they're being divided by these parallel lines that go through it. So these are the parallel lines going through it right here, right here, right here, and right here. So we see these parallel lines there. Does that make sense to you guys? Okay, so these are the parallel lines that are splitting up this line segment, these lines. All right, and so it says, what is LN? Well, LN is this whole thing from here to there. Well, I have to figure out what LN is the same way I would have done it before. So here's my green and yellow. Here's my yellow on this side. And here's my green here. Does that make sense to you guys? You see that? So the weird part about this one is that like there's like an extra line here, you see? You see there's like an extra line, you can kind of just ignore it almost. You see? And then it's green over yellow equals green over yellow. And so this here is LN. So I'll write ln over, this one is 2.6, equals, this one here is 1.4 plus 2.2. Well, 1.4 plus 2.2 is 3.6 over, this here is 2.4. You see? So you just have to figure out which line segments are proportional to each other. Well, this is over this, proportional to that over that. And then once they do that, then they just solve and they get ln is equal to 3.9. Does that make sense to you guys? Okay. Now, you're going to use the same one, except you're now going to solve for LM and MN. Okay. So go ahead and see if you can solve for LM. Try to figure out what the ratio is that you need to set up. So this is where you got to really engage and try and use your minds. Try and work on it. I understand, but just try and get started. Well, ln is from here to here, right? What? No, you have to figure it out what it is by using the ratios and then solving. So you have to figure out which are your segments that are being divided proportionally. Which are your segments that are being divided proportionally? That's the question. Let's try to figure it out. Did you get it? Okay. It's basically the same thing you were doing before. You just have to figure out which are the sides. It's just a little bit more challenging because you have to figure out which are the sides. All right, so let's take a look. We have LM here. That's our first side. LM over this side here is 2.6. So LM over 2.6 has to equal the corresponding part on the other line. So that's 1.4 over 2.4. Then I multiply both sides by 2.6. And I get LM equals 1.4 times 2.6 divided by 2.4 is 1.5. Approximately 1.5. Okay.
So you do the same thing with MN too.
So to find MN now, well, now that I have LM, I could make MN my green and that, and I can use LM and 1.4. So I could say MN over LM, which is 1.5, equals 2.2 over 1.4. So you see how, each one of these lines, it splits this line and this line into different segments. Those are the ones that are corresponding to each other. Does that make sense? So it's like this is the same as this. Not the same, but this corresponds to this, and this corresponds to this. So this one over this one equals this one over this one. You guys see that? Is that pretty clear? So it's like you got to find the corresponding segments. Oh, this corresponds to this, this corresponds to this, this corresponds to that. Okay? So you have to be able to see that. Okay? And then here I just multiply by 1.5. And I get MN equals, what was that?
You don't cross multiply?
No, because you don't need to because mn is on the top. Yeah.
But you can.
You can cross multiply, but you end up doing the same math anyway. So it ends up being 2.4, approximately 2.4. Does that make sense? Any questions on that? Okay.
Okay, so if you cross multiply, it won't matter.
It ends up being the same thing because look, if you cross multiplied, you'd get 1.4 mn equals 2.2 times 1.5, right? But then you divide by 1.4, which is the exact thing what we had over here. 2.2 times 1.5 over 1.4. It's the same thing. Okay, good question. All right, next, back page, last theorem. Go ahead and read it. Triangle angle bisector theorem. What was that? No. He's just taking a test. All right. An angle bisector of a triangle divides the opposite side. First off, what does an angle bisector do to an angle? Bisects it, which means it cuts it into half. Right. Okay, an angle bisector of a triangle divides the opposite side. So here's the angle bisector. Divides this side into two segments. You see this? Dividing it into two segments whose lengths are proportional to the lengths of the other two sides. So what does that mean? It means, so these two segments are divided proportionally to these two segments. You see? So AB over AC, that's this one, AB over AC is equal to BD over DC. You see that? You guys see that? So the left over the right is equal to the left over the right. You see that? So, and if this was top or bottom, it doesn't matter. You just have to be on the same side of the angle bisector. You see? The left over the right is equal to the left over the right. You see? But it's dividing this line into two line segments. Okay? So what would an example look like? Go ahead and take a look at the example that's given. So I'm just going to do it my own way so you can just see me as I work it out, because I think sometimes that's a little easier. So just take a look, guys. Take a look. So here are my blues. You see my angle bisector splits up this blue side, and then here's my red sides. So it would end up being blue over blue, so 2x plus 1 over x plus 2 equals red over red. And which one do I put on top? If I put 2x plus 1 on top, which one do I put on top? 14 or 10?
14.
14, right? Bottom over top equals bottom over top, you see? 14 over 10. Now I do what? Cross multiply. So it becomes 10 times 2x plus 1 equals 14 times x plus 2. Then I distribute, exactly. So it becomes 20x plus 10 equals 14x plus 28.
And then you subtract.
Yep, I get the x's with the x's and the numbers with the numbers. So 14x from both sides. I get 6x plus 10 equals 28. Then I subtract 10 from both sides. And I get 6x equals 18. Thank you, sir. Have a nice day. Good to see you, Matthew. Divide both sides by 6. And I get x equals 3. Does that make sense? Now, if it asked me for RV, then I just plug it in. 3 plus 2 equals 5. You see? If it asked me for VT, I'd plug it in. 2 times 3 plus 1 is 6 plus 1, which is 7. You see? Does that make sense? Okay. So there you go. Got it?
Yeah, please.
All right. So a lot of visual stuff, a lot of information here today. But go ahead and do example, do check it out number 4. Do check it out number 4. Go ahead. I will highlight, look, I will highlight the sides, right? Blue, blue, red, and red. If you want to, like on tests or homeworks or whatever, you can use a colored pencil and do the same thing that I do on the board. So remember, it's blue over blue, red over red, right? Check which the line segment is splitting up. Doesn't matter which one goes first now, as long as you're consistent.
How many minutes do we have in class?
About 20.
Here.
Yeah.
So you write y divided by 2.
Mm-hmm.
Just for the fraction.
Mm-hmm. Marcus, are you done already? Okay. So let's take a look. Y over 2, so blue over 4.5. It's a little weird because there's a fraction there, but you just got to deal with it. Equals red over red. Which one do I put on top? Y minus 2. Good. Y minus 2 over 8. What do I do now? Cross multiply. So I get 8 times y over 2 equals 4.5 times y minus 2.
Then you distribute.
Mm-hmm. 8 times y is 8y, divided by 2 is just 4y. Because I'm dividing by 2, not multiplying. You see, 8 times y, this 8 doesn't get distributed to the 2.
Wait, why are you dividing?
Because it's y over 2.
Oh, that's what I reported.
Y over 2, then I'm multiplying by 8, right? If I did 8 times 3 over 2, that would be 8 times 3 is 24 over 2 is 12, right? Okay, so I'm doing the same thing, just 8 times y over 2, so I get 8y, but then divide by 2 and I get 4y, okay? Then here I distribute in 4.5y.
Wait, so you just do 8 divided by 2.
Yeah, it's just 8 divided by 2. That's the easiest way to think about it. Look, I've got 2 on the bottom, so 8 divided by 2 is 4.
I thought you can't divide it unless it has like a y. Unless the 2 has a y.
No, I mean, if I'm just doing 8 times y over 2, it's just 8 divided by 2 is 4, so it's 4y. So I'm not dividing the y, I'm just dividing by a number. Okay? 4.5 times y minus 2 times 4.5 is 9. Okay? What do I do now?
You
I subtract 4.5y from both sides to get it over here with the other y. And I get negative 0.5y equals negative 9. What do I do now? I divide by negative 0.5, right?
Mhm.
Divide by negative 0.5. Okay, and I get, that crosses out. And I'm left with y equals, negative divided by negative is positive. Dividing by 0.5 is the same as multiplying by,
Wait, why'd you subtract that 4.5 if it's,
to get it to this side.
but shouldn't you add it because you was trying to subtract it to 9?
No, this is minus 9, so it's not, this would have to be negative.
Oh, okay, I get it.
Okay, so if I divide by 0.5, it's the same as multiplying by 2. So 2 times 9 is 18. And if you don't believe me, you could do 9 divided by 0.5, and you get, move the decimal place over once, 5 goes into 9 once, minus 5 is 4, bring down the 0, 5 goes into 40 8 times. So 90 divided by 0.5 is 18. So there you go. Y is equal to 18. But am I done? No, I have to plug it in. DC is 18 over 2, which is 9. And AC is 18 minus 2, which is 6. So what did we do, guys? What happened with a lot of you guys? This messed you up, the y over 2. What else messed you up? The fact that that's 4.5. But the reality is this is just algebra. So what do we do? This over this. So y over 2 over 4.5 equals this over this. Y minus 2 over 8. Cross multiply and solve for y, yes?
Could we do another problem like this one?
I don't necessarily have, we have them in the Kahoot.
This over here.
We have them in the Kahoot, yep.
Can I ask you a question? So like, when you just satisfy AC and DC, you just have to put y equals 18, right? You don't have to put it like,
No, you have to then plug it in and then solve. Yeah. Okay.
So 116.5 divided by 9.0.
He's like, so
No, 9 divided by 0.5 to show that 9 divided by 0.5 is 18.
Can I take a picture of this?
Yeah.
Or I can just write it
All
down?
right, we're about to do our Kahoot.
Or can I just write it down?
Just take a picture of it for now, just so I can get the Kahoot up, please. Thank you. All right. Here we go.
Oh, where's my laptop?
Did you move the decimal over to the right? Like that?
Yeah, because they're dividing by a decimal, right? So if you divide by a decimal, right?
Yeah. Okay, I was just wondering.
Yeah, no, good.
Can I do it on here?
Mhm.
Oh, come on.
What the heck is that? Wait, no initials, just name?
Just put your name. It's good to go, so you guys can get done and you can take your quiz. Whoever is loading is very creative. That one,
What is that?
are we all in? Who's not in?
I can join it later.
1863397. You in? All right, here we go. Find the length of DG.
Of DG?
So you have to set up the ratios first. Make sure you set up the right ratios. And then solve. Alright, let's take a look, guys. 24, this over this, so 24 over 32 equals dg over 40. Okay? So I want to simplify the fraction first so I can divide both these by 8. I get 3 over 4 equals dg over 40. Then multiply both sides by 40. I hope you guys are paying attention. Or just why don't you take a seat then. 40 times 3 is 120 over 4 equals dg. 120 over 4 is 30. So dg equals 30. As long as you got the right answer. So dg is 30. Find the length of Rn.
What's the same
Okay,
thing?
so it's almost exactly the same thing.
But a little different.
Yeah. Olivia, pay attention. First thing is to figure out which ratio to set up. How do I set up the right ratio? So this one, it's Rn over what? 10 equals what? 5 over 8. Then I multiply both sides by 10. I get Rn equals 50 over 8, which is equal to 6.25.
So you're supposed to times 10 to both sides.
What?
So you're supposed to like 3 times 10 to both 5 and 8.
No, not 5 and 8. No.
Just the numerator?
Because it's like 10 over 1.
Oh, okay.
Alright, find TU and RS. So, are they parallel, yes or no?
Yeah.
Are they parallel, yes or no? What do you have to do?
Divide them.
You have to divide them. So you do 90 over 72, and that should be equal to what? 67.5 over 54. So you have to check if those are equal, guys. 90 over 72 is the same thing as 5 over 4. And this is also the same thing as 5 over 4 if I simplify that. Okay? Does that make sense? Yeah, exactly. Alright, so since they're the same, it means the lines are parallel.
Okay, what was the answer to the last one again?
6.25.
Well, what did you do to get that? Because I only know 5 over 8.
What?
I did
50 over 8.
50 over 8, and you just divided it.
No, it's a little good. Somebody put it on.
Okay, look at this one, guys. You're trying to find this segment from here to here. You're trying to find this segment.
Which,
So this is my x. How do I do it? Same way you've been doing it.
is this one gonna be on the quiz like that?
Not exactly like that.
It's gonna be on like one of these.
All of these questions are similar to the ones on the quiz.
Oh, okay.
Alright, so look, x over 275 equals 250 over 240. You see?
Yeah.
So I have to multiply by 275, and you kind of need a calculator for this one. And you end up, forget exactly what the right answer is. Oh, you end up with something like 286. You understand? But the exact math isn't what's important. The exact thing that's important is how to know the ratio. It's this over this equals this over this. Does that make sense? You have to be able to set that ratio up. If you cannot see that ratio, then you're going to have a tough time.
Hey.
Okay, solve for x. Shh. This one you guys can all do, so do it. Solve for x.
What answer? Was it 286?
Yeah, it was 286. Look, here's my angle bisector. So here's my blue and my blue. Here's my red and my red. So now that I know that, I just gotta set up my ratios.
I got kicked out.
How can we?
Look, right over blue
Oh,
over
you're not
blue and red over red. They're not
Okay.
congruent, they're
That's what
similar.
I was like, that made no sense.
No, they're similar. So it'd be x plus 1 over x minus 2 equals 16 over 12. You guys see this? X plus 1 over x minus 2, so right over left equals right over left, 16 over 12. I gotta cross multiply, I get 12 times x plus 1 equals 16 times x minus 2, which ends up with x being 11. X equals 11.
Yes.
Alright, you guys gotta start your quiz.
Haha, you're
Nicely
behind.
done. Alright, start your quiz.
What did I get?
What?
What did I get?
You got the top.
I did.
Yeah.
I guess you were third.
I know I'm pretty smart, right?
Alright guys, do your quiz. Do your quiz. Do your quiz. You guys got about 5 minutes.
It's do your things.
5 minutes. Do you think I have enough time? History here.
Yep.
I'm a little confused on this one.
Olivia. Thank you.
Do you have an extra sheet of paper?
Whoa. Whoa. Did you say incomplete too? Do you have a time setting on this?
Thank you so much.
I can reopen it for you though. Or they can answer one.